today we'll be looking at new software, which is Climate Consultant 6.0. So let's load it. Once it's loaded, just press next, next. We'll start a new project, and my type will be a residential type, and my unit will be metric. If you are based in the US, you can go with empirical. I will start from scratch and just show you how to download the data file. And click on this install weather site. Now please select your particular region. For me it's Southern Pacific, Australia, and Melbourne. Yep. Make sure you download this EPW file, and once it's downloaded, just go back to your software, press cancel, and now open the existing file and just go wherever you downloaded the file. Open. Alright, so it will show up some basic data. Now it's very important to select your comfort model. You can read this description and select accordingly, but I'm going right now with the ASHRAE standard because that's commonly used everywhere. Let's just proceed. Alright, so you can see some basic description. With the one in the white box, you can edit them, but for now I'm just taking it to it. Let's move further. Next. This is the temperature graph for the particular region. I will come back to this later. We will skip to the most important one, which is psychometric. Alright, so these are some design strategies which you need to implement, and these are the number of hours that you need to make sure that it's 8760 to make it 100% comfortable. As you can see in the legend as well, it's right now it's 100%, but if I unselect any of the design strategies, it reduces the percentage. Yeah, let's see. Alright, so the heating is alone contributing to almost 80-90%. Alright, let's just go one by one, and you can just select you can ask the software to select the best design strategies by clicking it on this box. So it has already generated a pre-designed one, but we'll design it by scratch. So let's just go and understand what does everything means. The first is the sunshade. First, let's just talk about the graph. On the x-axis, it's just your normal air temperature, so right from -10 to 40 degrees, whereas on the y is the humidity, or say the moisture content there, and this blue box is the comfortable zone box, on which the left side on the left hand side is the summer clothing, whereas the right one is the winter clothing. The very first is the sunshade. Sunshading is contributing to say 368 hours and 4.2% contribution, but if you see carefully, it's not actually contributing to a comfortable hours, so there's no point of considering it right now. The next is the high thermal mass, which is contributing fairly enough, like 178 hours, and it is also increasing our comfortable hours. So high thermal mass is nothing but an ability of any material which is used in the construction of a house or say building. For instance, concrete wall or brick wall, which has an ability to store heat inside and releases it gradually. And the next is the night fused, which is similar to the high thermal mass. The only difference here is it releases heat only when the surrounding temperature is cooled down, especially in the night times. So that's the reason it's called night fused. Alright, so next is direct evaporating cooling, which is contributing 184 hours, but not contributing towards our comfortable hours. So we might not consider that. But direct evaporating cooling is like a mechanical cooling method in which, say, the water is evaporated into air for lowering the surrounding air temperature. And the two-stage evaporating cooling is also not contributing to a comfortable hours, but two-stage evaporating cooling is an advanced version of direct one, and which lowers the temperature as well as lessens the humidity in the air. So, and for these are not contributing enough, so we might not consider them. The next is the natural ventilation cooling, like doors, windows, but even they are not, that's not contributing to a comfortable R, so we will not consider that. The next is the fan ventilation, even that is not contributing. Yeah, the internal heat is contributing fairly enough, 40%. So the internal heat is the heat generated from all the appliances or even from us like human beings. There's certain amount of heat released from various appliances. For instance, if you go in the winter, cold winter days in the kitchen, you will see that it's quite warm as compared to any other rooms because of the various appliances in there, and they release certain amount of heat. So that's contributing, say, 40%. So we'll consider that. The next is the low mass and high mass, and they are also contributing enough. So we'll consider both of them. And low mass, the example of low mass could be, say, timber or carpet or say plasterboard, whereas high mass could be something solid like concrete wall or brick wall. The next is the wind protection outdoor. So that is not contributing, but wind protection outdoor refers to all your balconies and courtyards. So all that things comes inside this, but that's not contributing. And the next important one is humidification, which is like just adding moisture to the air, but even that is not contributing, so we'll not consider that. The next is dehumidification, which shall contribute. Yep, that is contributing fairly enough. Which is like removing the moisture and reducing the humidity from the air. So yeah, that is contributing. The next two are the cooling, which are contributing slightly, and yeah, that's how you make your 100% and complete your 8760 comfortable hours. So as you can see in our graph, everything is green, which is good, and that's what we need to know about this in the psychometric chart. Once you've completed the designing, you can just press next, and here the software will give you some design guidelines which you can click and refer to it. um, let's just move to our very first chart and see all the charts which are important. Alright, so the very first one is the temperature chart, which shows the various temperature range. As you can read the legend, the highest recorded is marked as in the small circle, which is in Feb. Now, if you're wondering that like of which particular year this temperature is taken out, so let me tell you that it is not of any particular year. It is like a typical meteorological year, say past historic weather data from past 10 to 30 years. So that's what the software consider while taking this temperature. So it's not like past 5 or 1 2 years. So in Victoria, Melbourne, the highest temperature was recorded in the month of Feb, which was close enough to 39 degrees, whereas the lowest was say 0 degrees in July. And as you can see, the light gray box, which indicates the most comfortable zone in summer weather. This is around 25 to say 26 degrees is considered the most comfortable ones. Whereas in winters, that's the dark gray, which is around say 20 to 24 degrees. And to the next graph. So in this, you can see that the red line indicates the dry bulb mean, whereas the black one indicates the wet bulb. So the dry bulb is nothing but your normal air temperature, whereas the wet bulb refers to say how cool the air gets when evaporating. What's and the closer the difference between the red and black line, the greater the humidity is. Like here in July and June, the black and red lines are fairly close enough, so there will be greater humidity. Mm, so let's move on to the next graph. Yes, graph that you might consider. This is the ground temperature graph, which might be useful for the geotech engineers for knowing the temperature of the ground at various depths, say zero point 0.5 meters, 2 meters, and 4 meters at each month or say each period of the year. So the next important chart is this sun shedding chart. So it is plotted on the red, yellow, and blue dots. So the red one indicates the number of hours which are above the comfort zone, whereas the yellow ones represents within the comfort zone and the blue ones represents below the comfort zone. You can design this manually as well just by checking this box of shading calculator and close this, and you can design it accordingly. And one more thing that you can also add on obstructions to your structure, like for instance if you want to add some neighboring buildings, then just click on neighboring structure. Say the structure is 30 meters and 5 meter away from a structure, so it will consider that as well while calculation. So I think that's it with